Question: What is Amazon Elastic Compute Cloud, Amazon EC2? Amazon Elastic Compute Cloud, Amazon EC2, is a web service that provides resizable compute capacity in the cloud. It is designed to make web-scale computing easier for developers. Question: What can I do with Amazon EC2? Just as Amazon Simple Storage Service, Amazon S3, enables storage in the cloud, Amazon EC2 enables compute in the cloud. Amazon EC2's simple web service interface allows you to obtain and configure capacity with minimal friction. It provides you with complete control of your computing resources and lets you run on Amazon's proven computing environment. Amazon EC2 reduces the time required to obtain and boot new server instances to minutes, allowing you to quickly scale capacity, both up and down, as your computing requirements change. Amazon EC2 changes the economics of computing by allowing you to pay only for capacity that you actually use. Question: How can I get started with Amazon EC2? To sign up for Amazon EC2, click the Sign Up for this web service button on the Amazon EC2 detail page. You must have an Amazon Web Services account to access this service. If you do not already have one, you will be prompted to create one when you begin the Amazon EC2 sign-up process. After signing up, please refer to the Amazon EC2 documentation, which includes our Getting Started guide. Question: Why am I asked to verify my phone number when signing up for Amazon EC2? Amazon EC2 registration requires you to have a valid phone number and email address on file with AWS in case we ever need to contact you. Verifying your phone number takes only a couple of minutes and involves receiving a phone call during the registration process and entering a PIN number using the phone keypad. Question: What can developers now do that they could not before? Until now, small developers did not have the capital to acquire massive compute resources and ensure they had the capacity they needed to handle unexpected spikes in load. Amazon EC2 enables any developer to leverage Amazon's own benefits of massive scale with no upfront investment or performance compromises. Developers are now free to innovate, knowing that no matter how successful their businesses become, it will be inexpensive and simple to ensure they have the compute capacity they need to meet their business requirements. The elastic nature of the service allows developers to instantly scale to meet spikes in traffic or demand. When computing requirements unexpectedly change, up or down, Amazon EC2 can instantly respond, meaning that developers have the ability to control how many resources are in use at any given point in time. In contrast, traditional hosting services generally provide a fixed number of resources for a fixed amount of time, meaning that users have a limited ability to easily respond when their usage is rapidly changing, unpredictable, or is known to experience large peaks at various intervals. Question: How do I run systems in the Amazon EC2 environment? Once you have set up your account and select or create your AMIs, you are ready to boot your instance. You can start your AMI on any number of on-demand instances by using the Run Instances API call. You simply need to indicate how many instances you wish to launch. If you wish to run more than 20 on-demand instances, complete the Amazon EC2 instance request form. If Amazon EC2 is able to fulfill your request, Run Instances will return success, and we will start launching your instances. You can check on the status of your instances using the Describe Instances API call. You can also programmatically terminate any number of your instances using the Terminate Instances API call. If you have a running instance using an Amazon EBS boot partition, you can also use the Stop Instances API call to release the compute resources but preserve the data on the boot partition. You can use the Start Instances API when you are ready to restart the associated instance with the Amazon EBS boot partition. In addition, you have the option to use spot instances to reduce your computing costs when you have flexibility in when your applications can run. Read more about spot instances for a more detailed explanation on how spot instances work. If you prefer, you can also perform all these actions from the AWS Management Console or through the command line using our command line tools, which have been implemented with this web service API. Question: What is the difference between using the local instance store in Amazon Elastic Block Storage, Amazon EBS, for the root device? When you launch your Amazon EC2 instances, you have the ability to store your root device data on Amazon EBS or the local instance store. By using Amazon EBS, data on the root device will persist independently from the lifetime of the instance. This enables you to stop and restart the instance at a subsequent time, which is similar to shutting down your laptop and restarting it when you need it again. Alternatively, the local instance store only persists during the life of the instance. This is an inexpensive way to launch instances where data is not stored to the root device. For example, Some customers use this option to run large websites where each instance is a clone to handle web traffic. Question: how quickly will systems be running? It typically takes less than 10 minutes from the issue of the run instances call to the point where all requested instances begin their boot sequences. This time is dependent on a number of factors including the size of your AMI, the number of instances you are launching, and how recently you have launched that AMI. Images launched for the first time may take slightly longer to boot. Question: how do I load and store my systems with Amazon EC2? Amazon EC2 allows you to set up and configure everything about your instances from your operating system up to your applications. An Amazon Machine Image, AMI, is simply a packaged-up environment that includes all the necessary bits to set up and boot your instance. Your AMIs are your unit of deployment. You might have just one AMI or you might compose your system out of several building block AMIs, for example, web servers, app servers, and databases. Amazon EC2 provides a number of tools to make creating an AMI easy. Once you create a custom AMI, you will need to bundle it. If you are bundling an image with a root device backed by Amazon EBS, you can simply use the bundle command in the AWS Management Console. If you are bundling an image with a boot partition on the instance store, then you will need to use the AMI tools to upload it to Amazon S3. Amazon EC2 uses Amazon EBS and Amazon S3 to provide reliable, scalable storage of your AMIs so that we can boot them when you ask us to do so. Or, if you want, you don't have to set up your own AMI from scratch. You can choose from a number of globally available AMIs that provide useful instances. For example, if you just want a simple Linux server, you can choose one of the standard Linux distribution AMIs. Question: how do I access my systems? The run instances call that initiates execution of your application stack will return a set of DNS names, one for each system that is being booted. This name can be used to access the system exactly as you would if it were in your own data center. You own that machine while your operating system stack is executing on it. Question: is Amazon EC2 used in conjunction with Amazon S3? Yes, Amazon EC2 is used jointly with Amazon Simple Storage Service, Amazon S3, for instances with root devices backed by local instance storage. By using Amazon S3, developers have access to the same highly scalable, reliable, fast, inexpensive data storage infrastructure that Amazon uses to run its own global network of websites. In order to execute systems in the Amazon EC2 environment, developers use the tools provided to load their Amazon Machine Images, AMIs, into Amazon S3 and to move them between Amazon S3 and Amazon EC2. See how do I load and store my systems with Amazon EC2? For more information about AMIs, we expect developers to find the combination of Amazon EC2 and Amazon S3 to be very useful. Amazon EC2 provides cheap, scalable compute in the cloud while Amazon S3 allows users to store their data reliably. Question: how many instances can I run in Amazon EC2? You are limited to running up to a total of 20 on-demand instances across the instance family, purchasing 20 reserved instances, and requesting spot instances per your dynamic spot limit per region. New AWS accounts may start with limits that are lower than the limits described here. Certain instance types are further limited per region. You have to check the table in the EC2 FAQ to see the maximum number of instances per type of instance. Note that CC2.8 is large, CG1.4 is large, Hi1.4 is large, HS1.8 is large, CR1.8 is large, G2, D2, and I2 instances are not available in all regions. If you need more instances, complete the Amazon EC2 instance request form with your use case and your instance increase will be considered. Limit increases are tied to the region they were requested for. Question: are there any limitations in sending email from EC2 instances? Yes. In order to maintain the quality of EC2 addresses for sending email, we enforce default limits on the amount of email that can be sent from EC2 accounts. If you wish to send larger amounts of email from EC2, you can apply to have these limits removed from your account by filling out this form. Question: how quickly can I scale my capacity both up and down? Amazon EC2 provides a truly elastic computing environment. Amazon EC2 enables you to increase or decrease capacity within minutes, not hours or days. You can commission one, hundreds or even thousands of server instances simultaneously. When you need more instances, you simply call run instances, and Amazon EC2 will typically set up your new instances in a matter of minutes. Of course, because this is all controlled with web service APIs, your application can automatically scale itself up and down depending on its needs. Question: What operating system environments are supported? Amazon EC2 currently supports a variety of operating systems including Amazon Linux, Ubuntu, Windows Server, Red Hat Enterprise Linux, SUSE Linux Enterprises Server, Fedora, Debian, CentOS, Gentoo Linux, Oracle Linux, and FreeBSD. We are looking for ways to expand it to other platforms. Question: Does Amazon EC2 use ECC memory? In our experience, ECC memory is necessary for server infrastructure, and all the hardware underlying Amazon EC2 uses ECC memory. Question: How is this service different than a plain hosting service? Traditional hosting services generally provide a pre-configured resource for a fixed amount of time and at a predetermined cost. Amazon EC2 differs fundamentally in the flexibility, control and significant cost savings it offers developers, allowing them to treat Amazon EC2 as their own personal data center with the benefit of Amazon.com's robust infrastructure. When computing requirements unexpectedly change, up or down, Amazon EC2 can instantly respond, meaning that developers have the ability to control how many resources are in use at any given point in time. In contrast, traditional hosting services generally provide a fixed number of resources for a fixed amount of time, meaning that users have a limited ability to easily respond when their usage is rapidly changing, unpredictable, or is known to experience large peaks at various intervals. Secondly, many hosting services don't provide full control over the compute resources being provided. Using Amazon EC2, developers can choose not only to initiate or shut down instances at any time, they can completely customize the configuration of their instances to suit their needs, and change it at any time. Most hosting services cater more towards groups of users with similar system requirements, and so offer limited ability to change these. Finally, with Amazon EC2, developers enjoy the benefit of paying only for their actual resource consumption, and at very low rates. Most hosting services require users to pay a fixed, upfront fee irrespective of their actual computing power used, and so users risk overbuying resources to compensate for the inability to quickly scale up resources within a short time frame. Check the next chapter, Billing.